let us consider another example of time value of money, where we will look at the concept of present value. Consider a case where your child is currently 5 years old and you want to make an investment so that you get an amount of money when the child is 20 years old. Basically, you want to make an investment to save some money for the child's college education. Now you have a specific goal in mind that you want, let's say, 10 lakh rupees at the end of 20 years. And you know that a bank gives, let's say, 10% of interest per annum. So now you want to find out how much money should you invest currently so that you get 10 lakh rupees at the end of 15 years. Basically, when the child is 20 years old, the tenure of your investment will be 15 years because you are starting the investment when your child is 5 years old. So this 10 lakh is the future value, whereas this investment that you have to determine is the present value. So in general, the present value of a cash flow due in n years in the future is the amount which, if it were on hand today, would grow to equal the future amount. Now typically, if you have the value of the initial investment, that is the present value of the investment, and you know the interest along with the tenure, then basically by using the concept of compounding, you can find the future value. So let's say this is PV1 at the beginning of the tenure which is being invested. Now at the end of the first year, basically your PV2 for the second year becomes PV1 plus the interest accrued in the first year. Now similarly, whatever interest you accrue here is added to PV2 to arrive at PV3, which becomes the principal or the present value for the third year, and so on. So this is the concept of compounding when you're trying to find out the future value with the present value known to you. However, in cases where you know the future value and you want to find the present value, the concept is known as discounting instead of compounding. So if you are going this way, that is you want to find the present value, it is known as discounting, and if you are going this way, it is compounding. So basically, discounting is nothing but simply the reverse of compounding. Now let's take this example at hand and try to figure out how to perform the calculations. So the example at hand is to find out the amount that needs to be invested in order to get rupees 50,000 after 15 years at 9% interest rate per annum compounded annually. So let's draw the time scale. So this is 0, this is 15, and then you have 1, 2, 3 and so on. The present value is not known. The future value is 50,000 rupees. The tenure is 15 years and the interest rate is 9% per annum, which is compounded annually. So at the end of every year, the amount is being compounded. So now the formula for future value is FV is equal to PV into 1 plus R by 100 to the power n. So here we have to find the present value. So present value, or is equal to, so we'll keep PV on one side and take everything else on the other side. So our formula becomes FV divided by 1 plus R by 100 to the power n, or present value is equal to, now future value is 50,000, 1 plus R is 9%, so 9 by 100, n is 15 because the tenure is 15, so 50,000 divided by 1 plus 0.09 to the power 15, so this is 50,000 divided by 1.09 to the power 15, so present value is equal to 50,000 divided by, let me put my calculator here, so 1.09 x to the power y 15, so this is 3.64, so 3.64, so since 3.64 is in the denominator, we'll do 1 by x and then multiply it by 50,000, so this is equal to 13726.9. We can round it off to 13727 rupees. So basically, if we invest 13,727 rupees today at 9% interest compounded annually, then at the end of 15 years, the investment will grow to an amount of 50,000 rupees.